Hi, hello everybody. First of all, I want to thank everybody on Alba Orbital because you're doing something very, very grateful for the community and very, very good product you have here. Well, we are not satellite manufacturers, but we do some parts for satellites that probably will give you some ideas on how to develop your next project. I'm going to talk about composite additive manufacturing for developing nanosatellites and deployers. Okay, well, the company name is CRP. CRP is a group of companies with different capabilities, different technologies. The first of all is our main company in Italy, in Modena. Does CNC machining and 3D printing of metallic components. The next one is CRP technology. It's the one I'm representing today. It does SLS 3D printing with our WinForm materials. And we also have other two subsidiaries, one in North Carolina, in USA, and recently opened an office in Dubai as well. Yeah, well, we are in Modena, Italy. I don't know how much you guys know about Italy. In Modena is where we have Ferrari, Lamborghini, Maserati, Pagani. So we were good at going fast on the ground. So that's where we started. We started developing 3D printed parts for motorsports and then for automotive components. And then we say, okay, well, if we go fast on the ground, why don't we go into the space? So we started looking for different companies where we could develop some projects for aerospace. And one of these is Alba Orbital as well. And aerospace, avio, and drones as well. So we are working now in all these industries. This is what we do. This is very representative image. What you see there is a 3D printing machine being sinterizing a component, different components in that moment. So what we have is the machine is like an oven. Okay, so you spray some powder, you heat it up, and then there's a laser. What you can see there, there's a laser sinterizing, heating up just the parts where the section of the part that's going to be built. Then it goes layer by layer by layer. At the end, you take out of the oven like a cake, where inside the cake you have all these parts. You start cleaning up all those parts, and you get all the components that you printed. We have different printers of different sizes. The biggest printers we have is 500 millimeters per 500 millimeters per 500 millimeters in height. So imagine a cube of 500 millimeters. All that you can place inside can be printed. Okay, so we can achieve to print a very, very big satellite fully 3D printed. Now, and then we have some other machines. We have a total of 20 machines across all the three facilities. We are certified ISO 9001, and also we are certified AS 9100. Well, first of all, WinForm, when you see that, is the family of materials that we have developed. I will talk about the mechanical characteristics about the materials afterwards. But first of all, I want to tell you about the technology. What is amazing about 3D printing is that you can design and manufacture almost any shape, any design you want. So, in case of your products, you don't have to be thinking about, okay, I can machine these, how I'm going to manufacture these with any other technology. You just think it and you can print it, okay? So that's the cool stuff about this, and that's what is so disruptive about this technology. You can have any shape, you don't have to worry about undercuts or complex features. You can have high level of customization. Any part that you put into the machine might be the same, but you can have some customization, some markings, some special features for any other product, and they will come out of the printer like that. No? So, and also the time to market that you can achieve with this technology is, I don't know how many of you have passed through my booth on the presentation area. We have some satellites that can be manufactured in a couple of days, clean them, and be delivered in less than 1 week. So that's very, very fascinating about this technology. Instead of waiting for a month to have a molded part, or weeks or even months to have a machine part. You know? So at the end, what you can have is a flight-ready component, okay, but you just need to put all your electronics and do all your testing and put it into the pod and send it out into the space, okay. So with very lightweight components, resisting to different temperatures from minus 40 degrees to up to 170, 180 Celsius degrees, okay. And not only that, because you can also think about some tooling, some mock-ups that you may need to realize to speed up your process, your manufacturing of your components. So that's also another thing to have into consideration with this technology. In our WinForm family of materials, we have 10 different materials. They are all a polyamide base of the material, plus glass fibers or carbon fibers. This is the, let's say, the innovative thing about our materials is that we put these fibers to add mechanical strength, mechanical properties, thermal properties, and to improve the overall characteristics of the 3D printed materials. You know, so we have 4 carbon fiber materials. We have 4 glass fiber materials. We have materials with different capabilities, like fire resistant. Some of them are more elastic, some of them more rigid. Depending on where you're looking, we can find one of our materials that might have the specifications you need for your project. Also, these parts can also be machined afterwards. Maybe if you're looking for more precise tolerance or more specific features that cannot have the right tolerance with the 3D printing technology, it can be machined afterwards to have those constraints that you need. No. Okay, these are the 4 materials that we sell the most. Okay, these are the ones we propose the more. All of these 4 materials have passed the ESA, NASA, and JAXA certifications for outgassing. Okay, so that's good to know in your industry. The first 2 on the left, they are carbon fiber reinforced materials. Just to give you some idea of the density, it's 1.1 grams per cubic centimeter. An aluminum, a common aluminum might be around 2.8 grams per cubic centimeter. So we're talking about a material which is almost 3 times lighter than aluminum. Okay, with mechanical properties of you can see a tensile strength of 84 megapascal. That for the main application that we are doing on the industry are more than enough. Okay, the heat deflection temperature, the material can arrive to up to 170 degrees, or even more with WinForm SP, 186, without losing the mechanical properties of the material, keeping the strength in its place. What you see the difference between XT and SP is the SP is more rigid material. The base on the material is more rigid, while SP is more elastic. That's depending on what you're looking for. It can be one or the other. And on the right side, what we have is the glass fiber reinforced materials, which are not as strong mechanically as the carbon fiber reinforced material, but they offer the non-conductibility of the material, okay, which is quite important for some applications. So the same, we have GT, which is more elastic, Helix, which is more rigid. Also, a good thing about this material, it can be post-processed, and the surface finish you can obtain about the material is very, very good. It's very, we can achieve up to 1.6 of roughness. So these two materials are, these materials have the capability of being fire retardant. Okay, I don't know if on your industry is well needed these characteristics. But for example, a very cool application is the one you see on the top right. These are supports for automotive cells for the battery packs for the electrical vehicles. This material has, being fire retardant, has the property that in case of venting, of the batteries heating up, the material doesn't burns itself, and also it allows the non-conductibility between the different cells. So this is the newly released material. Okay, this is an improved material from our carbon fiber reinforced materials. Okay, this resists to even higher temperatures and resists to has a stronger matrix inside, so the tensile strength is even higher than the other materials. The only problem is that we are still waiting for the outgassing certifications, but as soon as we will have it, we will propose it to you again. And just to summarize why you should consider our WinForm materials and our SLS technology is because we have the best tensile strength per density unit in the market. So you can have the lightest part with the highest tensile strength. We comply to multiple certifications, the outgassing, the ultraviolet, the non-conductivity, the fire resistant. The materials resist to very high temperatures. They have a very low weight. They have very good strength, and also because of the fire resistant properties of some materials. Now I'm going to talk to you about some case studies. Unfortunately, a couple of these have been already explained on here. The first one is the Alba pot. We have developed with Alba pot the cover. It was a great project, very tough, because we had to contain all the satellites inside the pot without breaking the cover when during the launch. I know we have struggled with Alba Orbit to develop this and to have a very good components and a good product. So if you see the pot they have displayed on the presentation room, you will see, you can touch it and feel it, the robustness of the cover, and also the deployment, the cover for the deployment. The other project was Joe's satellite, which was our first approach to produce a fully 3D printed satellite. So we developed with him all the structure, and so the next thing you had to do is just to put the electronics and place it into the pod and launch it. So this is really cool application. This is a CubeSat, a 3-unit CubeSat we developed with Lisa. It's a University of Paris. Okay, we developed with them the structure of their CubeSat. It's a very big structure, so we're talking about almost 450 millimeters long. So all the reinforced inside, all the We put also some inserts inside to fix all the different components. So also this was very extreme application. Just to give you some other case studies about some other industries, this is where we were born on the wind tunnel applications, doing the mock-ups for, in this case, Leonardo AW609. It was a tilt rotor. It's a plane, an aircraft they were developing, and they had to test on the wind tunnel, so we developed for them all the mock-up. If you see that plane, it seems small, but it's 1.8 meter long with a 1.6 meter wingspan, and it's been 3D printed, and they choose us because of the smoothness of the surface, and also for the rigidity of the material. This is another application. This is a Tundra M. It's a military drone. It's used for surveillance. It's a 1.5 meter diameter drone. So we did with them a mix of materials. We developed the case with WinForm SP to be more elastic in order to support all the forces, so put all the electronics inside, and being watertight. So in case of heavy rain or heavy wind, it can resist and be watertight. And the arms were done in a more rigid material, which is WinForm XT 2.0, in order to resist all the loads from the rotors. And that's it. Thank you very much. You have my contacts here. I invite you to visit our website, www.winform.com, and you can find all technical data sheets from the material. You can have all the certification and some other tests that we have done. Thanks.